This is video number 6 on solving equations, and on this video we're going to solve equations that require simplification. What does that mean? You're going to have to do distributive property and also combining like terms. Okay, and you will have variables on both sides, and we're even going to cover special cases. Let's jump right in. As you guys could see, we have two equations here that require simplification. Before we even do this, let's take a look at our notes briefly. This is the page of notes we've been working with all the unit long. And of course, an equation is like a scale, it's equal. And here are the steps to solving any equation. Step 1 is to simplify. That's what we need to do today on this video. And what does it mean to simplify? It means both distributive property and combining like terms, okay? So you always distribute first because that's really multiplication. And you always combine like terms at the end because that's just adding and subtracting. And we always multiply before adding and subtracting. Once we've simplified, once we've done step 1 and we've simplified, then you could think about isolating the variable on one side of the equation. What does that mean, get x by itself? Okay, so with that said, that's exactly what we're going to do here. Where's the x at? Is it on the left side or the right side of the equal sign? It's clearly on the right side. It's definitely not by itself. We need to simplify it first. See, we have parentheses and there's a multiplication of 3 right here. So there is distributive property that we need to do. So with that said, whenever I distribute, I like to circle what I'm going to distribute and then draw an arrow. 3 times 2x, that is 6x. Then I go back to the 3 and I distribute to the minus 4. 3 times minus 4, or you could consider it a negative 4. 3 times negative 4 is a negative 12, but we write it as a minus 12. So let's now bring down the equal sign and bring down the 24 on the left side. And here is what we call a simplified equation. We've distributed. There was no combining like terms. Like imagine if there was a plus x out here on the outside, then I'd have an x right here and the 6x that I'd be able to combine together. But there is no plus x, so that's all we could do. That's simplified. So now we can move on to the goal of getting x by itself on one side of the equal sign. Where's the x at? It's on the right side of this equal sign. Let's get it by itself. What do I get rid of first, the 6 or the 12? Well, you get rid of the 12. Why? X is what's important. 6 is with the x, kind of important. 12 is all by itself. Get rid of that one first. How do you get rid of that minus 12? Plus 12. What you do to one side, you must do to the other to maintain the equality, maintain balance. So on the left side, 24 plus 12, you can do that on a calculator, is 36. And you bring down the equal sign. 36 equals the minus 12 and the 12 ended up being 0. They eliminate. And 6x is the only thing that's left over on the right side. We're down to our last step. This is really saying 6 times x, 6 times x. I don't want the multiplication of 6. I want x all by itself. I don't want the multiplication of 6 in front of it. So how do I get rid of that? I do the opposite of multiplying by 6, which is dividing by 6. And of course, what you do to one side, you do to the other side. Therefore, your final answer is 6 on this side equals, that canceled out, x on that side. However, it's better to write it as x equals 6. Now, I want you guys to notice that my equal sign just kept coming down, down, down. That way, you stay organized, the left side from the right side, left side from the right side. So please try to keep that in mind when you're showing your work. Anyway, this is our answer. Let's move on. On this next one, we have a lot of simplification to do. On this first one, we only had distributive property, and that was already simple. But over here, we could simplify this. There is no distributive property, but there is combining like terms. And on the right side, there is distributive property and combining like terms because there's a 5 out here. So let's start by simplifying one side at a time. And I recommend this. Don't do both at the same time. I just say cover one up and, well, that's not covering it up. Hold on. Cover one up and just focus on one side. So there is no distributive property, but you do have an x and another x. And we are adding and subtracting. In this case, this is a positive x and another positive x. That's a total of 2 x's. And normally when I combine, I either like to circle or squiggly underline or underline. I want to circle this x and I want to circle that x. In my head, not, you don't do like the opposite of x or anything like that. You do it in your head. X plus x, what is that? That's 2 x's. And what about the minus 17? You just bring it down, minus 17. And again, bring down the equal sign. And that's all you could do on the left side. Let's simplify the right side now. Let me move this out of the way. And on the right side, we have distributed property because wherever you have parentheses, if there's a number in front or behind, if there's a number with no symbol, that means you're multiplying, and you're going to have to distribute that multiplication. Now, like I always say, distribute, circle what you're going to distribute, include the sign that's in front. So in this case, you're thinking negative 3 times x, that is a negative 3x. And then negative 3 times a negative 1, that's a positive 3. And what about the 5 that's out here in the front? Just bring it down, 5, right? So again, the 5 came down, negative 3 times x is negative 3x, negative 3 times negative 1 is positive 3. So you have these three terms, and now after that, you could combine the terms that are alike. That means x's with x's and numbers with numbers. Now, here's a negative 3x, there are no other x's, so you're not going to be able to combine the negative 3x with anything, so you might as well just bring it down right in front of that equal sign. Now, how about the 5 and the 3? You could actually combine a positive 5 with a positive 3. That'll give you a positive 8. So let's put a plus 8 right next to the negative 3x. And this is what we call a simplified equation. We distributed, we combine like terms. Over here, we combine like terms. This is simplified. Now we can move on to the goal. Step 2, the goal, getting x by itself, isolating x on one side of the equal sign. So think about it. Where's the x at? Is it on the left side of the equal sign or the right side of the equal sign? It's on both sides of the equal sign. So let's get rid of one of them, okay? I'm going to choose to get rid of the minus 3x by doing plus 3x. That'll get rid of it. What I do to one side, I do to the other side, plus 3x over here. So what do we get? 2x plus 3x, that is a total of 5x's. Bring down the minus 17, bring down the equal sign, and bring down whatever's left over on the right side. In this case, 8 was the only thing, that's why I brought that down. So now we have x on the left side only of the equal sign, and I need to get this x by itself. That means I don't want the 5 and I don't want the minus 17. Let's get rid of the minus 17 first by doing the opposite of minus 17, adding 17. Now we do to one side, do to the other. 8 plus 17, that is 25. And again, simply bringing down that equal sign. And on the left side, what do I have left? I only have the 5x, so I'm just going to bring that down and put it over here. And as you can see, it now says 5x equals 25, which actually means 5 times x equals 25. And you want x by itself. You don't want the multiplication of 5. So the way to get rid of that multiplication of 5 is to divide. To divide by 5. And what you do to one side, do to the other. Cancels out. Final answer is x equals 25 divided by 5 is 5. All right. I hope we get it. You have to distribute, then combine like terms, and you have to do one side at a time. Check it out. These are really fun, right? I know you guys don't get scared, right? We're not going to look at the whole thing. Again, I always recommend for you to look at one side at a time. So let me cover up the right side. Let's just focus in on the left side. Is there any parentheses where you have to distribute a number from the outside to the inside? No, there's no distributed property. How about combining like terms? Well, you have 1, 2, 3 terms. Out of those 3 terms, you actually could combine the numbers with the numbers. This 5x, you can't combine it with anything because there are no other x's. So if you want, you could simply bring down that 5x and then combine the negative 2 with the positive 1 in your head or on the calculator. Minus 2 plus 1, that is a minus 1. Okay, and then of course we're going to bring down the equal sign, just drop it down. And now that we have simplified the left side, there's nothing else we could do. You can't actually take away 1 from 5x. You can't. That's like saying I got $5 and I want to take away 1 apple. It doesn't make sense. You can't do it. Not like terms. Let's now simplify the right side. And on the right side, again, we have parentheses, which means we have distributed property, and there's an extra number, which means that we're going to have to combine after we distribute. Number one mistake that students make is that they see the 4 and the plus 5 and they add it and they put 9 and then they distribute the 9. That's already wrong. Okay, you cannot add before multiplying. You have to multiply first. That's why when we say simplify, you always try to distribute first. Distribute that positive 5. Positive 5 times x, that's positive 5x. Positive 5 times negative 1, that's a negative 5. What about this 4? Just bring it down right here. Put it right in front. Okay, and now you have these 3 terms, 1, 2, 3. Out of these 3 terms, what could you combine? X's with x's, and there are no other x's, so I can't combine 5x with anything, but I could combine the numbers with the numbers. Okay, so like I said, I can't combine the 5x with anything, so I'm just going to bring that down right next to the equal sign. And I could combine the 4 and the minus 5. You could do this in your head or on the calculator. 4 take away 5 on a calculator is minus 1. And at this point, you could see that this equation has the identical left side to the right side. It's identical, which means that x will be all real numbers, okay? Because you could plug in 0 right here and 0 right there, and it'll be a true statement. You could plug in 10 right here and 10 right there, right? 50 minus 1 is 49. 50 minus 1 is 49. It's a true statement also. You could plug in any number you want. So at this point, you could say x equals all real numbers, or you could say infinite solutions, or you could type in IMS, infinitely many solutions, right? Anyhow, let's say you didn't see that right off the bat, and you're like, I want to get x by itself on one side of the equal sign. Where is it at? It's on both sides. I don't want it on both sides. Okay, then get rid of one of them, right? Subtract 5x, subtract 5x, cancels out. What do you have left? You have a negative 1 equals a negative 1. Is that true? Yes. When is it true? It's always true. Always true. So that's when you could say x could be all real numbers, or you could say infinite solutions, or you could just type in IMS. That also means infinitely many solutions. Okay. This is a special case problem, and as you could probably guess on this slide, I'm focusing in on special case problems. So if this one was a IMS, infinitely many solutions, this other one's probably going to be a no solution, and it is. Check it out. Let's pretend we didn't know that. How do you solve equations? Well, you simplify one side at a time. So again, don't look at the whole thing and get freaked out. Cover one side up and just focus in on the left side. So distribute first before combining like terms. A negative 4 times negative 3x, that's a positive 12x. Negative 4 times a negative 5, that's a positive 20. Bring down the minus x, just write it right here. And we have distributed. Now, do we have any terms that we could combine? We have 1, 2, 3 terms. Out of those 3 terms, we could combine the x's with the x's. In other words, 12x take away 1x is 11x's. Bring down the plus 20, bring down the equal sign, and now you could focus in on simplifying the right side. And on the right side, again, you start with distributive property. Negative 3 times negative x, that's a positive 3x. A negative times a negative is a positive. And a negative 3 times a positive 7, that's a negative 21. And what do we do with this 8x right here? We simply bring it down. So let's bring that down, 8x. And out of these 3 terms, 1, 2, 3, what could we combine? Remember, you could combine like terms. That means x's with x's and numbers with numbers. So you could combine the 8x with the 3x. And what is 8x plus 3x? That's a total of 11x's. And what about that minus 21? You simply bring it down. So you can have a minus 21 right there. And if you continue to solve, you're thinking, okay, now that I've simplified, now I want to get x by itself on one side of the equal sign. And I have x's on both sides, and that doesn't work, right? I want to get rid of one of them. So I'm going to get rid of this one by doing the opposite of 11x. That means I'm going to subtract 11x. That'll cancel out because 11x take away 11x is 0. And when you do to one side, you do to the other, take away 11x over here, but it also cancels out. So what do I have left? Well, the equal sign comes down. On the left side, I have 20. On the right side, I have negative 21. And what do you think about that? 20, a positive 20 equals negative 21? That's impossible. We say no, as in no solution, okay? Those are my special cases. There's one more type of question I want to review on this video, which we kind of already have seen. It's those that we solve involving fractions. But specifically, I want to focus in on those involving fractions and distributive property. Like, let me just review with this one right here, okay? We should have already learned from previous videos that you could get rid of any fraction by multiplying everything by the denominator of the fraction you want to get rid of. So you could multiply this by 3, which would cancel out, this by 3, and that by 3, and that'll get rid of the 2/3. You won't have a fraction anymore. But then you have to deal with this denominator and that denominator and that denominator. So it's a lot easier to get rid of all fractions at the same time by multiplying everything by the LCD. the LCD, the lowest common denominator. That we learned that back when we added and subtracted fractions. So the thought process should be go to your biggest number and ask your biggest denominator, that is, and ask yourself, could I change the other ones to become 6? Well, this one's already 6. That's fantastic. 2, yeah, that could become 6. 2 times 6, 2 times 3 is 6. And 3 could also become 6. So luckily, the biggest denominator here happens to be the LCD. And if you multiply everything by the LCD, all the fractions will cancel out. Let me show you. I'm going to multiply everything by 6. 6 right there, 6 right there, 6 right there, and 6 right there. Notice I put whoops, I forgot that last one. Notice that I put the 6 up on the numerator position because one option is to actually do 6 times 2, which is 12, and then divide it by 3. 12 divided by 3 is 4, and we have an x right next to it, right? Or instead of saying 6 times 2 is 12 divided by 3, you could have said 6 divided by 3 is 2, and then 2 times 2 is still 4 with the x. So either way is fine. You could multiply first, then cancel, or you could just cancel first. Like, it's really easy to cancel a 6 with a 6. What do you have left? Well, you have the minus 1. So let's write that down, minus 1. Let's bring down the equal sign. And then over here, 6 divided by 2, 6 divided by 2. Why do I say 6? Because 1 times 6 is 6. 6 divided by 2 is 3 with an x. So we're going to have a 3x on this side. And then over here, the 6's cancel. And what do we have left? We have a beautiful plus 5. So here's my new equation with no fractions. Again, I got rid of all fractions at the same time by multiplying by the LCD, which in this case was 6. And I guess I could stop here, but I'm going to keep going. Let's get rid of that 3x by subtracting 3x, subtracting 3x. That way we could have x's only on one side. 4x, take away 3x is 1x. You don't have to put a 1 in front of it. Bring down the minus 1, bring down the equal sign, bring down the 5 that was left over. So you have x minus 1 equals 5. Final step, add 1, x equals 6. There's your answer. Okay, so this was just a question that we've already done in the past. We got rid of all fractions at the same time by multiplying everything by the LCD. I'm talking about everything by the LCD. Now, I want to look at one more type of equation that has distributive property and fractions involved. And we're going to be able to get rid of those fractions by multiplying everything by the LCD, just like we did before, okay? This is from a WSP 2.4, guys, from your homework. So anyways, one option is to distribute 1/2 times 5 and 1/2 times 2. But, you know, multiplying fractions, it's not that fun. Actually, it's not bad at all. But you could get rid of the fraction by multiplying everything by the denominator of 2. Now, check this out. You got to be very careful because when I multiply everything by 2, it'll get rid of the fraction. So I'm going to put times 2 here and times 2 over there. Now, I know you're thinking, wait a minute, Salgado, you just said multiply everything by 2. So why didn't you put a times 2 next to the 5? And why didn't you put a times 2 next to the 2h? The answer is because whatever I do to this guy, because of distributive property, it's like if I did it to these guys as well. Okay, let me repeat that one more time. When I said get rid of the fractions by multiplying everything by the denominator, I only put a times 2 and a times 2 here because distributive property exists. So whatever I do to this outside guy that's going to get distributed to the 5 and to the negative 2h, whatever I do to this, it's like doing it to these guys as well. It would be incorrect for me to put a times 2 here and a times 2 there. So don't do that. Whatever you do to this outside guy, it's like if you did it to those inside guys. So right here, just by putting a times 2 here and a times 2 over there, it truly is multiplying everything by that LCD of 2, okay? So what happens? Well, the 2 on top and the 2 on the bottom cancel out, and what we have left is a 1 parenthesis 5 minus 2h. And of course, distributing that 1 doesn't change anything, so I'm going to have a 5 minus 2h without parentheses. Bring down the equal sign, bring down that equal sign, and over here, the 2 and the 2 cancel out, and I have a nice, beautiful h. And now at this point, it goes back to the goal of solving a simplified equation, which is to get h by itself on one side of the equal sign. So since I have a number already on the left side, I might as well move this one over to get h onto the right side. So we are going to get rid of that minus 2h by adding 2h. And what you do to one side, do to the other, add 2h. What do I have left? I have a 5 equaling, what is 1h plus 2 h's? That's a total of 3 h's, which really means 3 times h. And of course, we don't want the multiplication of 3 in front of h, so I'm going to get rid of that multiplication with division. Now you do to one side, do to the other, and there's your answer. That cancels out. H equals 5/3. Of course, it's better to write it as h equals 5/3 instead of 5/3 equals h. H equals 5/3. So there was a great example of getting rid of fractions, but you got to be careful not to multiply these guys by that denominator, because whatever you do to this outside guy, it's like if you actually did it to those inside guys. Shall we see another? I'm not sure. I think we're good, right? Actually, let's do one more. Let's take a look at, I don't know, 17 or 18. Let's do it 18, right? So yes, you could distribute 1/3 times n, get 1/3 n, 1/3 times 1, get a fraction 1/3, 1/6 times, but you could get rid of the fractions instead, right? How? By multiplying everything by the denominator of the fraction that you want to get rid of. Now we do have two different fractions with the denominators 3 and 6. So let's think about the LCD of 3 and 6, and that would be 6. 6 is the biggest one. You could change 3 to become 6. So 6 is the LCD. So I'm going to get rid of both fractions by multiplying by 6. Multiplying by 6. As you could see, 6 on top divided by 3 on the bottom is 2. And 2 times that 1 will be a 2, but we still have those parentheses with the n plus 1. Okay. Once again, you might be thinking, wait a minute, Salgado, why didn't you multiply the n by 6 and the 1 by 6? Why didn't you multiply the 3n by 6 and the 5 by 6? Because that would be incorrect. Whatever I do to the outside term, it's like if I did it to the inside terms because of the distributive property that's eventually going to happen. And it's about to happen right here when I distribute the 2. So whatever I do to this 1/3, it's like if I did it to the n and to the 1. Okay, same deal here. The 6 and the 6 cancel out. So what do I have left? I have the 1, but I still have the parenthesis of 3n minus 5. And if you're thinking, why didn't I multiply the 3 times 6 and the 5 times 6? Because whatever I do to this fraction on the outside of the parenthesis, it's like if I did it to both inside terms, because distributive property will eventually happen. As you can see down here, this is where the distributive property happens on both of those terms. Let's not forget about that equal sign. But the trick is, or the main point here is, I got rid of fractions instead of distributing fractions. Just be careful, don't multiply the inside of those parentheses by that denominator. Okay, anyways, let's distribute and solve this thing. 2 times n is 2n, 2 times 1 is 2, bring down the equal sign, and 1 times 3n doesn't change anything, 3n minus 5. When you distribute 1, nothing changes. And now we get n by itself on one side. I'm going to get rid of the 2n by subtracting 2n. And we do to one side, do to the other, subtract 2n. We're going to have 2 equals 1n, you could just put n, minus 5. Minus 5. Okay, so now we need to get n by itself on the right side of the equal sign. All I do is get rid of that minus 5 by adding 5, plus 5 right here, plus 5 over there. Final answer will be 7 equals n, but of course better said n equals 7. I hope this helps.